solving 2x2 linear systems graphically, and then, so graphically will mean on the calculator, and then using substitution. Okay, so let me just start off by looking at this linear system here. So we're going to solve for x and y. So we have linear, it's linear because the power of x and y is either 0 or 1. Okay, and so we have 3x plus 2y equals 4, so that's one equation. And 5x minus 2y equals 8. So that's it. So that makes it a 2x2 linear systems. Okay, so 2 equations and 2 variables. All right, so we could see here on the right the graph of each of these equations. Okay, so a solution to a linear system is a point that satisfies both equations. Okay, so this intersection point right here is what we're going to be looking for. Okay, so to do it graphically, we're going to start by isolating y in each equation. Okay, so here in the first equation, we will simply subtract 3x from the 4 and then divide by 2. And then in the second equation, we will subtract 5x from 8 and divide by -2. I usually don't bother when I'm solving graphically. I usually don't bother simplifying these. Okay, I simply bring over the x term and then divide by the coefficient of y. Okay, so then the next step we're going to do is we're going to enter each function of y into the calculator. Okay, so we will go to our y equals, which I am here right here. And so then we have parentheses 4 minus 3x for that first equation, and parentheses divided by 2. And then we'll enter the next one, parentheses 8 minus 5x, and parentheses, and divided by -2. All right, so then after we enter each function of y into the calculator, we simply find the intersection graphically and adjust our window as needed. Okay, so to find the intersection, we will do second, calc, intersect. Actually, let's first actually take a look at the graph. First, to make sure we actually see the intersection. Okay, so here, my window does not allow me to see the intersection. So what I'm going to do is I'm going to hit zoom 6. So for the standard window here, zoom 6. And right there is our intersection point. Okay, so we don't need to adjust the window anymore. So we do second, trace, so to get the calc, and then scroll down to intersect. Or we can simply press 5. First curve means this is our first line, so we hit enter. Second curve, so this is our next line, so we hit enter. And there's only one intersection, so we can just simply hit enter next. Okay, so our intersection is x equals 1.5 and y equals -0.25. So that means that is our solution. There will be x equals 1.5, y equals -0.25, or we could put our answer as an ordered pair. So the x coordinate comma the y coordinate. Okay, so both of these are acceptable ways to answer what the solution to this system is. Okay, so once again, a solution to a system is a value of x and a value of y that satisfy both equations. Or if you have more equations, it would satisfy all equations. All right, I'm going to give you another example to try by solving this system here for x and y. Okay, press pause while you work on that. Okay, if you isolate y in each equation, you're going to get that from this. You subtract the x, so you get 3 minus x divided by 4. And for the next one, you add the 4x, so 6 plus 4x divided by 0.2. And then you enter each function of y into the calculator. Then hit graph. All right, so we see that we have the intersection here in our window, so we don't need to change our window. And then we do the intersection. So second, calc, intersect. Press enter, and press enter. And here's our intersection. So x is around -1.44 and y is around 1.11. Okay, so your solution could be written as this: x is around -1.44, y is around 1.11, or as an ordered pair around -1.44, 1.11. Okay, so I'm going to talk here a little bit about classifying the possible solutions of a linear system, a 2 by 2 linear system. Okay, so here are the possibilities for a 2 by 2 linear system. So if you take a look at the graphs, so a 2 by 2 linear system is going to be, each equation's graph is going to be a line. So those two lines might intersect once, in which case we have exactly one solution, and we say that that system is consistent and independent. The next one is that maybe both equations are have the same graph. So then in this case, we'll have infinitely many solutions, and so each solution is every point on the line. And again, we call it consistent since there is a solution, but dependent since there are infinitely many solutions. Okay, so we can have either exactly one solution, infinitely many solutions, or no solution if the two lines are parallel, so they don't intersect at all. In that case, we say that the system is inconsistent. Okay, so no solution means inconsistent. Okay, so you should make sure you get that in your notes to know this terminology. Okay, let's see how to solve a system using substitution. Okay, so the basic idea here is that we pick a variable to solve for in one of the two equations. So we would either solve for x or y in the first equation or x or y in the second equation. And usually the easiest one to solve for is the variable that has a coefficient of 1 or -1 in front. Okay, so the x has a 5, so I don't want that. That y has a -2, so I don't want that one if I can avoid it, just because, lots of times we'll have to deal with fractions. But that x has a coefficient of 1 in front of it, so I'm going to go to this second equation and solve for x. Okay, so here we have that. We'll subtract 4y from both sides. So x will equal -1 minus 4y. Okay, so then what we do is we take that x value and we substitute it in for the x in the other equation. Okay, so we substitute that into that equation, so we have 5x, so we have 5 times the x, -1 minus 4y minus 2y equals -16. Okay, and now what we'll do is we'll distribute this 5 into the first set of parentheses there. So we have -5 minus 20y minus 2y equals -16. So now what that does for us is it gets us an equation in terms of just one variable, so we solve for that variable there. So here we have -22y on the left side. We combine these two terms, and then I'll take that 5 and add it to the right side. So that will give us -16 plus 5, or -11. Right, now we simply isolate y by dividing both sides by -22. And so we get that y is equal to 1/2. So again, so to recap what we've done so far, we picked an equation, and in that equation we picked a variable to solve for. So we solved for x, then we took that value of x, put it into the other equation, and then solved for y using that. So then what we do is we take this y value and put it back into the second equation for that y to find out what x is. Alternatively, we can put it right into there where we solved for x, and I actually like that idea better. Okay, so again, two options: put it back into the original second equation, or put it into the equation where we solved for x in the first place. So x is -1 minus 4y, so -1 minus 4 times 1/2, so it's -1 minus 2, or -3. All right, so the solution to that linear system is, we can write it as x equals -3, y equals 1/2, or we can write it as the ordered pair -3, 1/2. Okay, let me give you one to try. Okay, well, this system would be more easily solved using elimination. I'd like you to solve it using substitution to practice. Okay, press pause and work on it. All right, so while there are a few possibilities of where to start, I'm going to go ahead and start by isolating y in equation 1. So we get y equals 2x plus 4. So then we will plug it into the y in equation 2. So we get 3x plus 2x plus 4 equals negative 1. And then we will solve this for x. So we get 5x plus 4 equals negative 1. Bring over the 4 to get 5x equals negative 5. Divide by 5 to get x equals negative 1. Okay, so then we take that value of negative 1 and plug it into that value of y. Okay, so we get y is equal to 2. So our solution is the ordered pair negative 1 for x, comma 2 for y. All right, I'm going to give you one more of these. Okay, make sure you don't skip this one because I'm going to show you example of what sometimes is tricky for students. Okay, press pause and try this one. Okay, so we can go to the first equation and solve for x. We get x equals 3 plus 2y by bringing that 2y over. Next, we take that x and put it into the x that's being multiplied by negative 2. So we get negative 2 times 3 plus 2y plus this 4y equals 1. And then we distribute the negative 2. So we get negative 6 minus 4y plus this 4y equals 1. And then what happens here is these y's cancel out. So we get negative 6 equals 1. So negative 6 obviously does not equal 1. And so when you get something that looks like that, what happens is that there is no solution. Okay, so it turns out that these two lines here are parallel lines.